Welcome. If you watched my electronics videos, you'll see me interacting with a variety of tools on my workbench. Sometimes I actually have people ask questions about some of the tools, so I thought I'd do a few tool videos. This first video is going to be on optical tools, because one of the most frequent things I have people ask questions about is this AmScope trinocular microscope over here, which I use to do almost all of my soldering work these days. So I'm going to cover that. I'm going to cover an Optivisor, and I'm going to cover this Eakins inspection microscope that I just got. First of all, what is the problem? So when I was younger, maybe 15 years ago, I could just solder circuit boards like this with the naked eye. Just looking at it, I could solder transistors, capacitors, resistors, dip ICs, your typical through-hole components. But as you get older, your eyes start to not focus so well at different distances. This is why you need bifocals. So you get glasses, they're usually set up for a specific focal distance. These are my working glasses that I use to do my work during the day, set up to be in focus about the distance of a computer screen. So, about there or so, that's in focus. If you bring it closer, it's all blurry, you can't do anything. And the problem is, as humans, we've been taught when you need to see something bigger, you move it closer to your eye. That doesn't work if your eyes won't focus at that distance. I could get my bifocals out or get some reading glasses, then maybe this would be in focus at a reading distance, like here. That would be good because, you could actually solder at that distance, but it's still not going to be very big. Sometimes, you need to get something bigger so you can really get a good look at it. What you can do, you can hold it way up close to your eye, so right here is where that thing is in focus without my glasses. It's nice and big, I can see stuff pretty well. But you really don't want to solder at this distance from your eye. All kinds of crud could fly off there and get in your eye. Doesn't seem very wise to do that. So the first thing you might want to get is something called the Donegan Optivisor. This is an Optivisor here. They make a couple different versions. They make one with a glass lens and an acrylic lens. This is the glass version. There's maybe half a dozen different diopter options. This is a 4 diopter lens, which gives you about a 2 times magnification. If you're wearing glasses, what I read online tells me that the glasses are going to mess with the optical system a little bit because you've got an extra lens there. You're going to get maybe a little less working distance and a little more magnification. So with the naked eye through this thing, you're supposed to get 2 times and 10 inches working distance. Glasses, it'll be maybe more than 2 times and maybe less than 10 inches. So if I put it on, flip it down, right there the circuit board is in focus. I mean, that's pretty good working distance for my eyes. This is about 2 times magnification, so I can see it very well. Of course, it has 2 lenses. I have 2 eyes, so you got stereo vision. So you can get depth perception with it. This would be pretty useful. Of course, trying to actually solder hunched over like this, I think you'd get tired of that pretty quickly. So I'm pretty happy with this thing. I got it on Amazon for about 40 bucks. You can get the one with the acrylic lenses for a bit cheaper, but I would spend the extra just get the glass lenses. Maybe you might want to get a couple different lenses. For example, less diopter, like a 3 diopter or a 2 diopter would give you more working distance. They do have a magnifying loop that would fit on here and would flip down and give you an additional 2.5 times magnification on one eye. I don't think I need that flip down loop because I've got all these other things. They've also got some attachments that will put LED lights on it. Lighting is important, especially with magnification. It helps be able to see things. I have a very well lit office. I've got lights here, and I've got a big shop light up above that gives me plenty of light. Okay, so this is the new Eakins inspection camera I got. Saw this on the EV blog, just had to order one. The nice thing about it is it's an auto-focusing camera, so if we were to take this and we move it, it should keep auto-focusing, even though we've moved the item closer to the lens system. So this is the whole package. Comes from AliExpress. Maybe I paid about 600 bucks for it. Comes with everything you could possibly need. Got the autofocus camera, the zoom lens, the ring light, this little LCD monitor. Even comes with a crappy plastic mouse. Stand. The stand actually has this additional boom component, which would let you move the camera way out here if you wanted to. Not using that at the moment. So what this is going to do is to let me do PCB inspection, maybe soldering on a bigger screen. This is zoomed out all the way. You can see we're getting 15, 16, almost 17 centimeters in the field of view. We can zoom this sucker in. I mean, we're looking right up close at the paint on my ruler. Let's zoom back out. View some actual components. Here's one of my Atari 5200 boards. Put it under there. There's a tactile button. Oops, it kind of had some trouble focusing that. There's a tactile button. It's got this little focus window that tells it what it's actually going to focus in on. We could zoom into there. Whoops. Keep bumping this. Let's see just how close we can get. Can we get that close? Back it out a little. We're not doing the greatest job autofocusing. Come on. Let's try this again right on the edge of that trace. So what I may have to do, let me try just raising the thing a little bit. It only has so much range it can go through, and this board is, you know, it's no longer sitting flat down there like my ruler was. It's actually sitting a little bit higher, so move the microscope a little higher to compensate. Now maybe we can get zoomed in all the way. Maybe even a little higher. There we go. So now we're maximum zoomed in on that trace. Zoom back out. And now we're looking at the tactile button again. So yeah, you could use this for inspection, you could use it for soldering. Autofocus is kind of nice because you can tilt something and kind of get a look at the edge of it. Yeah, see, it's bringing this into focus each time I move it. And you know, you can get a better look at your solder joints than just looking at things only from the top. You can use the mouse, you can control it, so I can turn back to manual focus mode. Now if I stick anything in there, like my finger, it's not autofocusing. If you were soldering, you wouldn't want the autofocus because every time you moved your soldering iron in, the thing would try to refocus. One thing I did buy with it is this Barlow lens. This is a 0.3x Barlow, and I think this is going to make my life much easier because, you know, if you zoomed out all the way, it's still pretty well zoomed in. You know, you're not seeing a whole lot in there just because it's so far zoomed in. If we put the Barlow lens in, we'll get a much greater working distance and a much greater field of view. So let's put the Barlow in and see how that works. Screw it in on the bottom. Now we can take this thing, we can scoot it all the way up here. And now let me put the ring light back on. So look at the working distance I've got now. It's you know, it's taller than my ruler. That's, I don't know what, maybe 9-10 inches of working distance. That's incredible. The field of view. Now I've got 3 buttons worth of field of view, whereas before I could only see about 1 button. Where you are going to suffer though with the Barlow is the zoom in ability. So if I move Let's move my focusing rectangle over here. Start zooming in on this trace. Yeah, see, we've about maxed out as far as we can zoom, which is about half the zoom range of the scope. And the problem is, to continue zooming, we need even more working distance. We need to move this camera up off the stand and get the base of the camera like up here someplace to zoom in all the way with that Barlow. And the stand, it just doesn't go that high. So that seems to be one of the issues with using the 0.3 Barlow on this, is that, you know, the working distance, it gets so big. I kind of regret getting the LCD screen with it, because I'm not going to use this LCD screen. I'm going to use my nice big LCD screen that's back there. So this is probably just going in the box. Everything in this worked pretty well, with the exception of the power supply they shipped for this screen. They shipped me a 1 amp 12 volt power supply, and it would not power the screen. I had to go find a 1.5 amp power supply that I had laying around and use that instead. So just the overall build quality of the stand, it's much lighter duty than my Amscope stand. My Amscope stand, the tubes are like twice as thick, and the base is some kind of heavy cast metal, and just everything on the Amscope stand is heavier duty. But, you know, for what you're getting, this seems like an incredible value just because of the autofocus camera. The ring light, I don't even think you need the ring light. Look at that, it looks better without the ring light. And the reason I think it looks so good without the ring light is because this camera does have an automatic exposure built into it. So one of the drawbacks about this thing is there's no switch to be able to turn the autofocus on and off. You do actually have to move the mouse in here and click something, you know, and if you're doing a lot of work, that's going to be a lot of work moving the mouse, clicking. It would have been much nicer to have the autofocus on like a foot pedal, so you could just flick it on and off while you're soldering. So let's actually try soldering with this thing. I've got my soldering iron over here. I'm going to solder some 0.100 headers to this board. And we'll see how this works. There's a couple headers. It's kind of harder because I've already soldered some taller components on. Let's get it where we can see it under the camera. And be a little bit more difficult for me because I'm kind of staying out of the place I'd normally sit so that I can get this on video. So let me move this in. See the solder in the solder iron. There's one of them. See, it's one of the things, and it's maybe not easy to see this, but it's because you don't have stereo vision, you don't really get the depth perception, so it was hard for me there to tell how far the solder was away from the board. Now I kind of tacked two of these. I'm just gonna get my optivisor out, and I'm just gonna straighten them up. One, that's still not straight. It's one. It's kind of best done by feel. Okay, now we can put it back under the scope, and let's hit these pins. So one thing is, how much does the soldering iron mess up the autofocus? Not really bad. I mean, certainly if you get the soldering iron into the focusing zone there, it tends to wig it out a little bit. But there's an easy fix for that. We go over here and we'll just hit manual focus. Now we can move our soldering iron all we want, and it's not going to refocus. So let's hit these pins that need soldering. So the other thing you've kind of got to be able to do is to train yourself to be able to move these things where you're not necessarily looking. So I'm having to look forward instead of down at my workpiece. And it is a little bit, I mean, I can get the stuff in there without the depth perception, but it's not as easy as it could be. And we'll do the other 8 of them over here. Oops. Oops. Yeah, there we've got 2 headers in. You know, I think if I was actually sitting over here, instead of staying out of the camera shot, this would have been even a little easier. So you can see we're not even using the ring light, though this is plenty bright. I think that's just the automatic gain on the camera that's making it so bright to work under. So that's great. Now let's zoom in on it and see how our work looks like under zoom. So we'll go over here, turn the autofocus back on. Let's zoom in. There, so now we're kind of zoomed in on these solder joints. We can kind of tilt our board a little bit and it'll rezoom. That's one of the nice things about having the auto zoom camera. You know, I can get kind of an edge on look at some of these. Okay, let's talk about the microscope that I use. This is a stereo microscope, meaning you get a view in each eye. That's important because you get depth perception. You know, if you're moving your soldering iron tip up and down, the binocular vision allows you to see how far the soldering tip is above the board. That's really very useful. This is actually a trinocular microscope because it's got one for each eye, plus it's got this photo port back here where you can hook up a camera. Now they make 2 different kinds of trinocular microscopes. They make ones where the camera is live all the time, which would be really nice, and they make one like mine which has this lever that you pull out, and that flips a prism or a mirror or something and sends a light that was going to this eye in here. So you can either have 2 eyes or you can have 1 eye and 1 camera. So I think the idea is that, you know, you push this in, you do your stuff you want to do visually with your eyes, then you say, I want to take some pictures, pull that out, and now we've got the light path to the camera. So I've done several different things with the trinocular with the camera port. If you've watched my videos where I've recently done PC board inspection from JLC PCB or from Seed Studio, I did that with this very same camera that we're using right now to record this video, stuck on an adapter, mounted up there. I also did some stuff where I photographed like hot air soldering, and you could see the little balls of solder suspended in the solder paste melt, you know, and that do all that through there. So that this port is pretty useful, and I think anyone should probably get one with the trinocular port. It's only a little bit more expensive than the straight stereo, and you get that camera capability. Now the other thing we've got on here is a ring light. The ring light is fantastic because it puts out a lot of light. Is it adjustable? Yeah, there's an adjustment on the back where you can lower the light or raise it. Particularly as you increase magnification, it helps to get more and more light. So often when I'm soldering, I will be using the ring light. The other thing this has is a zoom. That's this knob here. So moving it one way or the other zooms. So you've seen me do, you know, inspection videos on full zoom. Typically when soldering, I'll have it zoomed out as far as possible because I want the largest field of view. Now talking about field of view, if you put a Barlow lens, this here is a Barlow lens, that will increase your field of view. So this 0.5x Barlow lens, that's an option for this microscope. You can buy those aftermarket, or you can get it in the package with your microscope. That increased my working distance and increased my field of view. Like without the Barlow, but you know, imagine if the microscope was down here lower, then you're moving your soldering iron, you're ramming your soldering iron into the ring light. You know, you want nice working distance, particularly if you're going to be doing surface mount work where you might have a hot air iron, which is really big and clunky, and you want to get it in there. So to actually focus this thing, focus is determined by how far it is from the workpiece. So you've got this knob here, which moves the microscope up and down, and that will affect the focus. With respect to the zoom, there's two different ways the focusing system can work. The more expensive ones will be such that as you zoom, it remains in focus the whole time. This is one of the cheaper ones, and as you zoom, you'll need to move closer to your workpiece. So every time you zoom, you need to move closer in, zoom closer in. You want to tilt the board up and look at the edge of the board. You know, maybe you'll have to move out. There's a lot of mucking around with that focus knob. And regarding stands, you can buy several different stands. This back here is a boom stand. You can see there's this heavy weighted base, which I've got all kinds of junk sitting on. This is some kind of heavy cast iron or cast aluminum or something. And out here comes a boom. Boom goes to this. You know, what I do is when I'm working, I have the stand way back here. I'll be soldering up here. The boom is kind of nice. They have several different options. One has no boom, which your microscope would be right over the base. There's also like a dual boom system where you'll be able to move back and forth real smoothly. Of course, you can move this one up and down. Move it way up here if you wanted to. I just can't stress just how heavy this thing is. This is really heavy duty, heavy metal, and just plain heavy to try to deal with. So if you want to mount your DSLR camera on top of this, you can't just hook your DSLR onto there, you have to get an adapter. This is the adapter. This has a T-mount and like a bayonet ring, and then you would just stuff it in there. Camera would be up here. Of course, I can't put the camera on there because we're recording from the camera right now. Plan on getting one of these if you have a DSLR. So finally, you might be asking, could I take my Ekins camera and mount it on top of my Amscope? Well, you can, but you need some special adapters. So this is not a C-mount, and it's also not the right optical power. But what I've managed to find on AliExpress is this adapter, which you'll screw into there. This is a 1/3 power adapter, and this one here is a 1/2 power adapter. I think the lower the power, the bigger field of view we're going to get. So I'm going to try swapping in this 1/3 power. So we'll just unscrew this tube. We'll screw this one in its place. And then we'll take and we'll mount our Ekins camera on the Amscope, see what happens. Okay, I've got the Ekins mounted to my Amscope via the new adapter I purchased. The adapter's in here. There's actually a focus parfocal adjustment ring that you can adjust up and down. I've got it adjusted kind of all the way up. Let's take a look at the picture we get on the screen. Okay, we are zoomed all the way out. Let's move the focusing ring around. There, we've got it zoomed in on the tactile buttons. Let's try looking at something interesting like the edge of the PC board. It's zoomed in on the edge reasonably well. Now if you get it too far out of whack, like if I really move this up here, you'll see it'll hunt. Let's see if I can actually, there, see it'll hunt way past the visible range. So you got to be prepared for that a little bit. But yeah, we can get a good picture at the edge of the board. Let's put the board down. Let's see how well I can zoom into it. So I think we probably reached the maximum of its zoom range there. It's not going any further. Well, yeah. There, we got a little bit better. Let's go down here. There, see, we're don't think we can get focused any better at that range. That's about the maximum there that we can zoom in. We can look over here and see where the focuser got to. Yeah, see, the focuser's all the way at the edge of its focusing ability. What I could do is I could go over here to the microscope, crank the microscope down a little bit, and now if we go back to the AM scope, well, it's kind of freaking out there a little bit, but it's back. Let's zoom in. Let's see if we can get full zoom. That's pretty close to it. And where's it at now? Yeah, it's 162. Yeah, so I just want to give a few closing thoughts about focusing. So when using the eyepieces, you're always focusing by moving the entire scope up and down, controlling this distance to the workpiece. There is no separate focusing control for the eyepieces. There's an adjustment to get the two eyepieces in sync to one another, but really to focus the thing, you move the whole scope up and down. As you zoom, it changes the optical focus and you need to move closer. So zooming is always a matter of zooming, moving closer, zooming, moving closer, etc. Now the camera has that built-in focusing ability, so it will autofocus and try to match its focus to whatever else you've got configured. As I demonstrated, as I zoomed, I didn't have to fuss with this knob because as I was zooming, the camera was autofocusing. But if I'd have looked through the eyepieces, I would have seen the eyepieces were no longer in focus. So probably the way you want to do this is you want to get, your image framed up where you want, in your eyepieces, zoomed into where you want, and then when it's time to go use the camera, you pull the lever, open up the camera port, and now you're looking through the camera. And then you can, tilt your board and stuff, and it will autofocus. So I hope that makes sense how all this focusing works together. So to sum it all up, I went over 3 different things today. I went over the Optivisor. This is great for stuffing components. If you want to sit really hunched over and solder, I think you could use it for soldering. Limited magnification ability with it, but very comfortable, lightweight, easy to flip on and off. The stereo microscope, this is what I've been using since like 2010. This thing is wonderful. You get binocular vision, so you get depth perception. Relatively cheap, you get a lot of value for your money. You've got a huge zoom capability. So then you've got things like the Ekins over here. Autofocus, which is wonderful because you can tilt the board and it'll focus. You can zoom and it'll focus. That all is great. You can project it on your big monitor, which is wonderful. The thing you're going to lose going from this to this is the binocular vision, which gives you depth perception. And I think I think you'll just get used to doing that by feel. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.